Diversity technique. Introduction. Superposition of a multiple signal at the receiver cause random amplitude variation, which is known as fading. A diversity mechanism is used to decrease the effect of fading is called diversity. Diversity techniques are used in wireless communications systems to primarily to improve performance over a fading radio channel. In diversity mechanism, multiple copies of the same data is transmitted to the receiver through multiple paths or channels, and the decision is made by the receiver without knowing to the transmitter. Diversity is a powerful communication technique that provides wireless link improvements at relatively low cost. Diversity exploits the random nature of radio propagation by finding independent signal paths for communication. These independent paths are highly uncorrelated need of diversity. If one radio path undergoes a deep fade, another independent path may have a strong signal. Modulator is given to the N channel, and N branch diversity combiner demodulates. Types of diversity. Fading can be classified into small scale and large scale fading. Small scale fades are characterized by deep and rampant amplitude fluctuation, which occurs as a mobile moves over distance of just a few wavelengths. For narrowband signal, this typically results in a Rayleigh faded envelope. In order to prevent deep fades from occurring, microscopic diversity techniques can exploit the rapidly changing signal. If the antenna elements of the receiver are separated by the fraction of the transmitted wavelength, then the various copies of the information signal are generically termed as branches can be compiled suitably as the strongest of them can be chosen at the receiving signal. Such a diversity technique is termed as antenna or space diversity. Types of diversity. First one, frequency diversity, time diversity, polarization diversity, angle diversity, space diversity. Frequency diversity. Frequency diversity is obtained by transmitting the same information on more than one carrier frequency or transmitting the same signal over different carrier frequency. In frequency diversity, only one antenna is needed. Frequency diversity. Theoretically, if the channels are uncorrelated, then the probability of simultaneous fading will be a product of the individual fading probabilities. Frequency diversity is often employed in microwave line of sight links. These links use frequency diversity multiplexing mode. Same information with different carrier. Frequency diversity. Serial to parallel transmitter. IFFT parallel to serial, and the channel consists of noise, multipath and clipping. Serial to parallel FFT and parallel to serial out. Time diversity. The information signal is transmitted repeatedly in time at regular intervals. The separation between the transmitting time should be greater than the coherence time Tc. The time interval depends on the fading rate and increases with the decrease in the rate of fading. Time domain, frequency domain. Polarization diversity. Polarization diversity requires two transmitter and two receiving antenna with different polarization. The transmission wave with two different polarization constitute two different paths. This provides only two different diversity branches. Polarization diversity uses half power by dividing the power between two different polarized antennas. Space diversity. In space diversity, there are multiple receiving antennas placed at different spatial locations, resulting in different, possibly independent receiving signals. The difference between the diversity scheme lies in the fact that the first two schemes, there is wastage of bandwidth due to duplication of the information signal to be sent. This problem is avoided in the remaining three schemes, but with the cost of the increased antenna complexity. Space diversity uses more than one antenna to receive signal. Angle diversity. Here, directional antennas are used to create independent copies of the transmitted signal over multiple paths. Thank you.